Hey everyone, welcome back to the Fortify mold design training series. Today we're going to be doing module 5, so finishing the mold. In this module we're going to be covering things like raised parting line, ventilation, things that aren't necessary for the function of the mold, but it's really just going to improve the mold, give you an extra like 10% performance boost when you're actually running this mold on a press. Besides that, we're going to touch a little bit on things you can do, design changes you can make to your mold to improve the printability of this mold. It's just going to help you once you get the mold on our printer. But with that, we'll jump right into the CAD. Alrighty, so we have our mold assembly that we've been working with for the other modules, the cap part. So to start, we'll talk about the raised parting line. A raised parting line is a really powerful tool that I like to use, especially when I'm working with very low viscosity plastics. So things with a high melt flow rating, plastics that flow super easily. What this raised parting line allows us to do is really concentrate the sealing surface of this mold so we can more effectively use the clamp tonnage of our machine to seal off our mold. So to start, we're just going to add this feature into the core half here. So we'll open up our core. So all a raised parting line really is it's actually a recession on the face of the mold 5 millimeters away from any area that sees plastic. So we're talking about the runner section here and then the outer wall of the part, this little ring there. So what we're going to do is we're just going to sketch, and we're actually going to do an offset function on those surfaces. So we'll do a chain here, and we'll select couple of those surfaces, and there we go. So we'll highlight all those surfaces and convert that to a loop, and we will go reselect that. We'll go 5, see if that gives us okay. So sometimes you're able to do this offset with this feature. In this case, since we're only getting the offset in this section of the mold, we're going to have to manually add in this offset, which is pretty simple, or it's simple enough. So we'll go ahead and we'll just do single offsets here. So we'll go 5 millimeters there. I skip that one, do 5 millimeters here. We'll connect these two guys with an arc. From there, we'll throw a couple more offsets in. Plus 5 on that, plus 5 on that. Connect these features, and we'll split them here. We'll do the same thing on this side, so we'll connect, and then we will split. From here, we'll just get a nice straight line down to the base of the mold, and we'll bring this part over here. So right now, the area that's highlighted in purple, this is going to be the area that is the raised section. So we'll do one more box around the outside of the mold, and then we will make sure to uninclude our alignment pins so those print properly. Okay, so we have the area that we're going to be cutting away. So now we'll just do an extruded cut and go with a solid. So we're just going to be extruding by 200 microns here. And still in this here. Oh, I'm still in the surface mode. Excuse me. One more thing I have to add. Ends. So we'll merge these two guys together. Just the extrusion. There we go. So now we have our raised parting line. So you can see we went from the full cross section of the mold being our parting line to just the area concentrated around the mold core area the area that sees plastic. That's the only area we're going to be sealing off with. So you can imagine if we're using 10 tons for our clamping tonnage for this mold, we've really concentrated that right around the area of the part. So we're going to be much more effective at sealing off that surface. So we'll go ahead and save that. We'll also, in the meantime, turn this into a solid. So we come back to our assembly here. We have our raised parting line. So that's for this part being a nylon material, that's really going to help us seal off the parting line and prevent any sort of flash that might occur. So from there, we're going to talk about venting. So venting for printed tools is super important, and we use it everywhere so that we can really keep our pressures low and extend the lifetime of these molds. So on a given mold, there's a ton of different areas where you're going to have ventilation. Things like your parting line itself, that's an area of ventilation. Ejector pins are great areas for ventilation. Inserts, they're also fantastic for ventilation. On this part, we don't have the ejector pins, but what we do have is a nice big insert here with a seam right around the base. So that's going to allow plastic to flow down into this deep rib section here and really flow without restriction, because air is going to be able to escape in between the seam, or in the seam created by the core and the insert. So that's really what we're fighting, is air buildup throughout the mold. So if we come to our cavity half here, as we can see, we have another deep kind of rib section around this center post. So as it stands right now, we don't have a good way to prevent air buildup at the base of this kind of feature. So we'll go ahead and we'll add in kind of the last tool I like to use for these areas would be a venting hole. So we're going to go ahead and add in our venting holes here. So we'll start out by sketching a circle around this post to give us our reference point. So we'll try to get somewhere centered there. We'll go ahead and throw a few circles around on this curve, trying to space them out roughly equally around this circle. We'll go ahead and constrain their dimensions so they're nice and equal. Okay, we'll add a diameter in here. So for these vent holes, we're going to go with a 0.5 millimeter diameter. And what that's going to do, that's going to allow us to properly vent down this hole without having any material flash down this hole either. So we have these holes in place. So we'll go ahead and extrude these holes out, remove them from the part so they can really act as a ventilation hole. So there we go. We have 1, 2, 3, 4 holes that are going to act as great sources of ventilation for plastic at the base of this rib. So we'll be able to easily fill out this area with minimal amount of pressure and really get a good fill around the whole radius or the whole diameter of this post. One last thing we're going to do on the back side here is we're actually going to open up these holes. So we're going to add a chamfer to the back edge of these holes. And what this is going to do is it's going to give the air a little more diameter to escape from the mold itself. So you can imagine if this is sitting in the back of a frame, these tiny holes could be pressed up against the metal. If we open them up, it's just going to give the air more volume to kind of move into. So at this point, we have ventilation on our cavity half. On our core half, we also have great ventilation. We have our raised parting line in position. So we have those secondary features that are really going to make our lives a lot easier when we run the mold, where it's going to give us a bigger processing window. It's going to allow us to more effectively use the clamping tonnage that the machine provides. And it's just going to make the mold processor's life a lot easier. So with all this stuff in place, let's get to some added features that you can use to help printing. So for these molds, we'll be printing them at somewhat of an angle. So typically this face here on the mold, that's going to be supported. There's not too many considerations we need to make to the mold itself. Rather, it's more so the insert areas where those inserts meet. Those kinds of areas are what we want to look at as far as printability. So we'll start off looking at the insert here. we're going to be printing this insert on this bottom face. The radii that we added in order to help improve the ease of inserting and removing the insert, that's going to help us a lot as far as printing this part and be able to remove it from the build plate itself. One area that I don't like quite as much is this flat surface here. So as designed, this surface is going to need to be supported because it's a little bit too large of an overhang. So one thing that we can do is add a slight draft to this area, and that's going to eliminate that overhang, allow us to not have to support this region, and successfully print this part. So we'll go ahead and open up the insert and add that feature in. So there's a couple ways to do this, but I am going to use the chamfer feature within Creo. I like this because I know that I can control the height of the chamfer by changing my settings to, specifying two distances on here. So we'll change this to a 1. We'll come to a 3 here. I guess we'll go to a 2 if that's allowed. Guess we can't satisfy that. All right. Well, we have our 1 millimeter chamfer here. That should be good enough to eliminate the size of this overhang a little bit, and that's really going to help us as far as printing this feature without having to support it. For the other areas on this mold or on this insert, we're pretty much good to go. We've broken a lot of our sharp corners. All these features should print really nicely. So we'll go ahead, we'll jump back to the mold assembly here, and we'll take a look at the other parts. So let's look at the mold cavity. So as far as the mold cavity goes, some of the things that we've actually already added in are this break here to the sharp edge that is the parting line. This is just going to allow these mold blocks to come together really nicely, and it really just helps the robustness of this area. Essentially, we're breaking a sharp corner, which is going to help us reduce any sort of stress concentrations. We come to the back side here. The other nice thing about this chamfer is it helps the mold printing process. So by adding this chamfer here, we're eliminating, again, kind of a sharp, tight through hole where it could be something that gets clogged with resin, something like that during the printing process. By adding this chamfer, it just allows resin to flow out during the printing process that much better. Now we'll take a look at the core half here. So this core half could definitely use a little bit of design work. So for this core half, we really have 2 printing orientations. We could print with this base section here, or we could print with this base section on our build plate. Either or, we need to add some chamfers in. So if we look at this base here, this sharp area, this without chamfers is going to be a nightmare for the printing process. So we'll go ahead and add a little chamfer around the base. I'll make that one. So for part removal off the build plate, this is going to be huge, just making your machine operator's life that much easier. We'll go ahead and we'll add some chamfers around the rest of this feature here. Okay. We're actually going to leave those 2 guys. Actually, we've got to add one more. Much better. So what these chamfers are really going to do, it's reducing, especially on this base area here, it's reducing the contact area with this little post feature, and it's going to allow this feature to remove that much easier from the build plate when you're actually removing the part. Otherwise, we have those seam chamfers in on this part. We've broken some sharp corners. So with that, this mold set is ready to print. So the last thing I like to do with every single mold I'm designing is I just like to take a look at how everything comes together in the assembly. So the things I'm looking for are, is the parting line truly in contact? So we can look right at the runner section here, and you can see the gap created by the raised parting line. But around the full part area, you can see exactly where the mold comes into contact with where the core and the cavity come into contact. So that's something I'm looking for every single time. What I also want to look at is how my insert fits into position. So I'm going to take a close look right at that seam, and I want to make sure that I have my gap in position, which we can visibly see there's a nice little gap there. And that's something that I'm looking for, because if you forget that, if you forget to add to this little offset, then you're not going to be able to use this insert. I want to check the alignment of my key feature here. So that all looks good. Everything has clearance, but it's a tight clearance. And these outer points, there's a clearance, again, a tight clearance, but we have clearance everywhere. So those are the kinds of things I'm looking for once I complete my mold design. Is, do I have my clearances? Is my parting line coming together? And those are really the main things. But at this point, this mold design is ready for printing. So we're ready to turn this into STLs, send this out to one of our printers, and get a printed mold set. So thanks everyone for tuning into this design series. Looking forward to hearing what everyone has to say. Have fun designing your molds, everyone.